All right, Chapter 9, Section 1, number 33. Interesting differential equation here. Y times y prime is equal to x times e to the negative y squared. And we have an initial condition right here, which makes this one an initial value problem. So we're looking for a specific solution rather than a general solution. Okay, separating the variables here, the first step wasn't too bad. This e to the negative y squared we wanted to bring over to the left. So we divided by it, leaving the y where it was up in the top. The y prime was a dy dx, so we multiplied the dx to the right side and got here. But anytime you see a fraction where the denominator has something to a negative power, that should kind of stand out to you as something weird right there. There's really no point in keeping a negative exponent in the denominator when we can bring it right up to the top level and make it a positive exponent. So that e to the negative y squared that was in the denominator now moves up to the numerator level and becomes e to the positive y squared. So that's your full separation of variables, trying now to anti-differentiate both sides. And here's where things get kind of interesting. The right side's pretty easy, but in the left side, two distinct parts to the integrand, and it looks like we could take the derivative of y squared and get that to match up with the y dy. So that sounds like a u substitution problem to me. So we're going to let u equal the exponent on the exponential factor, the y squared. Du then becomes a 2y dy. Getting rid of that 2, we're going to get a 1/2 du is equal to a y dy. So let's make our substitution then back to the original integral right up here. We're now going to get an e to the u. That takes care of the e to the y squared. The y dy, the secondary substitution, gets replaced by a 1/2 and a du. And again, the right side, no problem there, so we left that one just the same. Okay, so let's move things up a little bit and let's get working from here. Okay, evaluating that integral doesn't get easier than this. Integral of e to the u is e to the u. And on the right side, we've got a 1/2 x squared plus c. Now again, since this was an initial value problem with the ordered pair of 0, 2, now's the time then to indent and start doing a little bit of work. Nope, I lied again. Let's undo that substitution right there. Yeah, this is an x value and a y value right here, so we want to get y back in here. So since u was y squared, we resubstitute and get that, and now it's time to start working ahead. We replace all of the x's, now there's only one x there, with a 0, and the one y with a 2, and we get this odd value right here of a 1/2 e to the 4th is equal to a 1/2 times 0 squared plus c. Well, that whole term wipes out, so we just get c is equal to a 1/2 e to the 4th. Kind of an unusual value right there. So let's go back to where we were at this level right here and make that substitution now. So a strange looking equation, 1/2 e to the y squared is equal to 1/2 x squared plus our new c value of 1/2 e to the 4th. And from there then, the goal becomes let's solve that thing for y. So first thing we're going to do is multiply everything by 2, which took care of all the 1/2s right there. And then to get rid of an e, we did the natural log of the left and the natural log of the entire right side. It's going to be very tempting, and I can see a lot of people trying to distribute that natural log inside there, especially with that natural log of e to the 4th, which would work out really nicely. But remember, guys, there is no distributive property for natural logs. The natural log of a sum does not equal the sum of the logs. You cannot do this. All right, I'm sure a lot of people maybe thought to do that right there. That one does not work out, so we're going to get rid of all of that. Okay, so back to where we were then, guys. The natural log and the e cancel out. We just get a y squared, and this, unfortunately, is just going to remain the ugly thing that it is, natural log of x squared plus e to the 4th. We've got to get rid of that square now by doing a plus or minus square root on both sides, but now we need to remember that we never leave a plus or minus in the final answer to an initial value problem. We've got to go ahead and think about which case, the positive or negative, is going to get us this y value right here of -2. Now, it should be pretty obvious. Since all of y is just equal to a square root, if we want this to come out to be a negative number, it has to be the negative case. But this is always a good opportunity to check just to make sure things are right. So let's go ahead and do it. Let's put the 0 in there for x. 0 squared is 0 plus e to the 4th is just e to the 4th. Natural log of e to the 4th is 4. Square root of 4 is 2. And the opposite of that number is going to get us -2. So that's how we end up with this final answer right here. Y equals the opposite of the square root of the natural log of x squared plus e to the 4th.